Alright, this is Fall Exam Review, Worksheet 2. Let's look at some problems dealing with equation of tangent lines. So for number 1, what's the equation of tangent line to the curve sine pi x plus 9 cosine of pi y is equal to x squared y at 3, negative 1. So we've seen this type of problem before in previous worksheets. We find the derivative of this equation, which requires chain rule and implicit differentiation and product rule. So we go through all those steps. Sine pi x becomes cosine pi x times the derivative of pi x, which is pi. Cosine of pi y becomes negative sine of pi y times the derivative of pi y, which is pi times dy dx. And then x squared y, we got to go through product rule. So f prime g plus f times g prime. So g prime is the dy dx. And then we can just go ahead and plug in these ordered pairs for all the x and y's to determine, to find the slope. Plug in 3 in for x, plug in negative 1 in for y, and we're going to get cosine of 3 pi, which is simply just same thing as cosine of pi, which is negative 1, so negative pi. All this will cancel out because sine of negative pi, the same thing as sine of pi, which is 0, so all this goes away. Negative 6 plus 9 dy dx, and then we isolate dy dx by itself, and we get the slope, 9 minus pi over 9, and then we write the equation of our tangent line. Okay, for number 2, find the equation of tangent line to the curve f of x at pi equals 3, at x equals pi over 3. Okay, our function here is explicitly stated, so no need for implicit, but there are two separate functions here, so we're going to have to go through product rule. So f prime times g plus fg prime. Cosine 3x becomes negative sine 3x times 3 times the original g function, sine squared 2x minus pi, plus the original f function, cosine of 3x, times the derivative of the g prime is going to be the sine squared 2x minus pi. We can think of this as sine of 2x minus pi squared. So we go through chain rule, bring down the 2, keep the bracket, subtract 1 from the exponent, which is goes to 1. Multiply it by the inner function's derivative, so sine of u becomes cosine of u times u prime. So the derivative of 2x minus pi is simply 2x turns to 2, and pi is a constant, and it's going to go to 0. Okay. Once we have our derivative, plug in your x value, evaluate the derivative at this point, pi over 3. And once you plug everything in, we can begin to simplify. So sine of pi is simply 0, and that's going to just cancel everything here after it. That's being multiplied. But we're going to use this again. Sine of 2 pi over 3 minus pi, you can think of this as 2 pi over 3 minus 3 pi over 3 after finding common denominators. And 2 pi minus 3 pi gives us negative 1 pi over 3, which we're going to use later on, even though this cancels out to be 0. Cosine of pi times sine of 2 pi over 3 minus pi, which turns into 5 pi over 3, or it turns into negative pi over 3, which you can rewrite it as 5 pi over 3. And cosine of 2 pi over 3 minus pi is the same thing as cosine of 5 pi over 3. So really, we just have to evaluate this. Cosine of pi is negative 1. Sine of 5 pi over 3 is negative root 3 over 2 in the fourth quadrant. Cosine of 5 pi over 3 is 1/2. Multiply all this together, we get root 3. So here's our slope after we evaluated our derivative. So we have our slope, we have our ordered pair. To find the ordered pair, we need to plug this x value back into the original equation, and we replace every x we see with pi over 3, and we get cosine of pi, which is negative 1. Sine of 5 pi over 3 is negative root 3 over 2. We square that, and we get 3 over 4 times negative 1 is negative 3/4. So we have our ordered pair, pi over 3, negative 3/4. We have our slope, and now we have our equation of our tangent line. Okay, number 2, we want to, these are problems that deal with tangent to a curve and parallel, perpendicular, or perpendicular to a given line. So for part A, find all points x on the graph, x over x minus 2, with tangent lines perpendicular to the line y equals 2x plus 7. And then after that, the next part is to find the equation of these tangent lines. Okay, we're going to have to do this without looking at a graph, without having to graph it, but let me just first start off with a visual so we can so I can walk through the steps a little bit easier. So let's say we start off with x over x minus 2. So here's our function. Okay. We're trying to find the tangent, the line that is tangent to this curve. We see there's going to be two tangent lines that is tangent to the curve, and also with the restriction that it must be perpendicular to the line that is provided for us in the problem. So y equals 2x plus 7. So here's what we need to do. We need to find the slope of this line, okay? And we have the equation, so we can find the slope. Once we find the slope of this line, then we want to identify the perpendicular slope to that line, and we can find that using by finding the negative reciprocal of our first line. And then once we have the slope of this tangent line, then we can set the derivative of the function equal to the slope, because we want to find out when is or where is this graph going to have a slope that we're trying to target. Once we set them equal to each other, we can find the x values, and once we have the x values, then we can write the equation of these tangent lines. Okay. So here are the steps. We're going to find the derivative. We're then going to find the slope of the given line. From there, we can find the perpendicular slope of the line by just taking the negative reciprocal of our slope. Okay, next, we set the derivative function equal to the slope that we're after, this perpendicular slope. Once we have that, we can solve for x. Once we solve for x, we know this point. Once we have the point, we can plug into the function to find the ordered pair. And once we have the ordered pair, we'll have that information and the slope of the perpendicular slope, and then we can write the equation of our linear equation of our line. Okay, so first step, find the derivative. So x over x minus 2, we have to go through quotient rule. So f prime g minus f g prime all over g squared, and this reduces to be negative 2 over x minus 2 squared. Now we need to find information about the given line. So the line is y equals 2x plus 7. It's already in slope point-slope form, slope-intercept form. And from here we can identify the slope, which is simply 2. But that's not the slope that we want. We want the slope that is perpendicular to the line. So even though the slope is 2, the perpendicular slope after we take the negative reciprocal, or the opposite reciprocal, will simply be negative 1/2. So we want to find out when is this graph going to have a slope of negative 1/2. Okay, the way we find that is we set the derivative function equal to this perpendicular slope. Okay, so the derivative function negative 2 over x minus 2 quantity squared is equal to our slope that we're after, which is negative 1/2. Set them equal to each other, cross multiply, and we can distribute the exponent through, or we can expand and set equal to 0, factor out the x, solve for x, so we get x equals 0. Not only 0, but also at 4. So we have 2 points where the slope of the tangent line will be negative 1/2. And now we need to find the ordered pairs for those 2 points. So at 0, the y value is 0. At 4, we plug back into the original function, and we're going to get 4 over 4 minus 2, which is 4 over 2, which is 2. So we have our 2 ordered pairs, and we have our slope, so then we write the equation of our tangent line. Okay, first point is 0, 0. Our slope is negative 1/2, so plug into your point slope. Here's your second order pair, and your slope, and then point slope. Okay, part B. Find the equation similar to part A, but now we have a different function, but we're still looking for perpendicular slope to a given line. The only thing is we do have to do some work to rewrite this in form, so we can actually identify the slope. So solve for y, we get y equals negative 2x minus 4/3. We go through the same steps. We find the derivative of our function, go through chain rule. After we've identified the slope of the given line, we're going to find the opposite negative reciprocal. So the slope is negative 2. We take the opposite reciprocal, which is 1/2. We set the derivative equal to the slope that we're after. And then we can figure out the x value where the slope will be exactly 1/2. Okay, we solve for x, we'll get x equals 3. And now we can find the ordered pair, and then from there find the equation of tangent line. So plug 3 back into the original function. We get root 3, 3 minus 3, which is 0. So our ordered pair is 3, 0, and our slope is 1/2. And we plug in the point slope, and we can either leave it in this form or write it in slope-intercept. Okay. Part C, find the equation of tangent line that is parallel to a given line. So now, once we find the slope of this line, then we can just keep it. There's no need to change it because we just want a slope that's parallel. So go through the same steps, find the derivative, find the slope of the given line. In this case, after you get it into slope-intercept form, the slope is 3. We're going to hold on to that slope because we want a line. We want something that's parallel to the given line. So we're going to now set the derivative function equal to the slope that we're after. In this case, is 3. Solve for x. We get 1 and negative 1. So we're going to have two ordered pairs where the slope is going to be tangent to the graph and parallel to this line. Okay. So plug 1 and negative 1 back into the original function. We have our two ordered pairs, 1, 1, and negative 1, negative 1. They both have to have a slope of 3, and then we write the equation of our tangent line. Okay, problem number 3. The tangent to the curve, y equals our function, and parallel to the line, y equals 6 minus 1, at x equals which value. So we go through the same steps as before. We find the derivative function. We find the slope of the given line, which is 6. We set those pieces of information equal to each other. Set equal to 0, factor out the 6, and divide by 6. And we're going to get 2 and negative 1. And so we want to circle all that apply. So negative 1 and positive 2.